everyone. Thanks for tuning in and a very warm welcome to today's web seminar of the 5G-ACIA, the 5G Alliance for Connected Industries and Automation. This is already the second web seminar of the current series. About 3 weeks ago, we provided an overview of 5G for the industrial IoT in general. And today, as well as in the upcoming editions, we will deep dive a little bit into different topics, starting with industrial use cases and requirements now. So my name is Andreas Müller. In my day job, I'm the head of communication and network technology in Bosch Corporate Research in Stuttgart, Germany. But today I'm here in my capacity as the general chair of the 5G-ACIA, and I will have the pleasure to moderate this web seminar. And before we start looking at the topic of today, let me briefly introduce what 5G-ACIA is doing, in case that you don't know that yet. So, of course, we are looking into a 5G for Industry 4.0. And what we see here is that basically two major trends and major developments are coming together. On the one hand, we see the evolution towards 5G. And the difference of 5G compared to previous generations of mobile communications is that it's not just about connecting phones and connecting people, but from the very beginning, it was about connecting all kinds of things in the Internet of Things. And this opens up many new application areas, so industrial being one of them, but also automotive, agriculture, healthcare, and many more. At the same time, we have the developments towards Industry 4.0, the industrial IoT, and connectivity per se is a key enabler for that, so that we can establish cyber-physical production systems. And these two developments basically started independently of each other. But now if you bring them together, and merge basically 5G with the developments towards Industry 4.0, we can realize unprecedented levels of flexibility, efficiency, productivity, and ease of use. So basically, we can lift Industry 4.0 to the next level. However, in order to be able to unlock this huge potential, we need a close collaboration between the two different worlds that are now coming together. So on the one hand, the OT industry, that means the classical industrial domain, and on the other hand, the ICT industry driving the 5G activities. And now this is exactly what 5G-ACIA is about. So 5G-ACIA serves as a global forum for bringing all the relevant stakeholders together from the different domains in order to jointly develop, shape, and promote industrial 5G worldwide. And some of the major goals can be seen below. So it starts with establishing a common language. We want to make sure that the needs of the OT industry are reflected and probably considered in standardization and regulation. It's also then about understanding how we actually can use 5G in the industrial domain in an optimal way. We are identifying certification needs, testing needs, are working on corresponding frameworks for that. There's a lot of activities about ecosystem building, and also, of course, promoting industrial 5G worldwide, which is one of the reasons why we are having this web seminar today. And here you can see an overview of current members that we have. So as of today, we have 67 member organizations worldwide. I think it's already a very good balance between the OT industry, the ICT industry, and different regions around the globe, and we are still growing. So there are a couple of more organizations currently finalizing the paperwork. So I'm very confident that during the next web seminar in 3 weeks from now, we can already announce a couple of new members, which then further contributes to the success of 5G-ACIA. And if you are interested to learn more about us, so please feel free to visit our website. Probably most of you have done so already when registering for the webinar or web seminar today. And there you can also download all the white papers that we've published so far. And of course, there will be more exciting work coming up very soon. Okay, so that's a short introduction of 5G-ACIA. And let's have a look at the web seminar program again. So I mentioned this already 3 weeks ago. We gave an overview of 5G for the industrial IoT. I did this myself together with the General Vice Chair of Xueli An from Ericsson. Today, we are focusing on industrial use cases and requirements. And the next one will take place mid-August, where we will have a closer look at non-public 5G networks for manufacturing, which of course is a huge topic, where we have published also a white paper already, which has received quite some attention in the community. And the next time it will be a pleasure to have Adnan Salmi from Nokia deep diving a little bit into this topic, who is also the rapporteur of the white paper that we have published on that topic. But let's focus on industrial use cases and requirements and today's web seminar first. Before we get started, so here's some general housekeeping information. This web seminar should also be kept as interactive as possible, so therefore please feel free to put any questions that you might have during the presentation already in the dedicated Q&A window, which you can see on the right-hand side usually on the screen. And then we will try at the end of the web seminar to address as many questions as possible. Depends a little bit, of course, on how much time there is left and how many questions will pop up. If we cannot deal with any questions during the meeting, we will try our best to answer them afterwards offline so that you receive some message from us afterwards with the corresponding answer and clarification. The slides and the recorded version of the web seminar will be made available afterwards. So we have done it already for the first web seminar, which you can watch again on our website. The same will happen now with today's web seminar, so you don't have to take any screenshots and so on. You can just sit back and focus on the actual content. Of course, everybody is muted by default, so don't worry if you speak up and nobody is listening to you, because we simply can't. If you experience any technical problems during the presentation, so please use the chat window or directly reach out to the 5G-ACIA office via this email address, and then we will try our best to fix your problems. Of course, we see what is possible, but sometimes these are also easy things that may be easily handled. And we also want to keep it interactive by introducing a couple of live polls to get your feedback on and input on various topics. I think this is of interest for all of us in the call, hopefully. And here I would just like to ask you to actively participate in these polls by filling in and submitting the corresponding forms that pop up whenever we start a poll. So usually this should be very easy questions and something that just can be answered right away. And the gut feeling is typically the best thing that you can express here. And to test this, we start with two very simple live polls right away. So at the beginning, it's always good to know who is in the call, who the audience is. So therefore, we would be very much interested in understanding which stakeholder group you belong to. And now we can hopefully see a live poll popping up. So are you from the ICT industry? That would be A. Are you from the OT industry, more a classical industrial player? That would be B. Academia would be C. And others, I mean, can be regulator or a governmental organization and so on, whatever, would be D. So just make a choice, indicate to us where you're from, and then press the submit button. And then in a couple of seconds, we can see the results. And these are exactly, of course, the stakeholder groups that we also have represented in 5G-ACIA, ICT, OT, and academia as the main drivers of the activities. It's ended, and now results should be here. And if I remember right, so that's very similar to the first web seminar that we have organized. So the majority obviously comes from the ICT industry, almost 50%. And then we have a good balance between OT, academia, and others. So that's in line with the previous event. But of course, it would be nice to have even a better balance between ICT and OT. So maybe in future we can further work on that. So that's the first question. And the second question, which is always of interest, is where do people come from? So it would be nice if you could also briefly indicate from which region you are from, which continent basically. You see the options here. A would be Africa, B, Asia, C, Australia, D, Europe, E, North America, and F, South America. So it should also be easy to answer. I guess we don't need a full minute. Maybe we can already stop the poll a bit earlier. And also here, 5G-ACIA has the ambition to really represent all the regions in the world, because 5G is a global standard, of course. Industrial automation markets are global markets, so you usually don't develop a product just for a single country. So therefore, it's very important to have always the global perspective in mind. And also here, of course, ideally we would have a good diversity and distribution of different regions in the audience today. now in a second we should be able to see the results. So obviously, yeah, for North America, it's very early today, so that's not very surprising, and South America as well. So we try to shift the times a little bit of this web seminar so that sometimes it's more suitable for Asia, for Europe, and maybe for some other events more suitable for North America. But obviously, majority also today comes from Europe. So thanks everyone for getting up early then. Okay, so that was just a short introduction, and always good to know who is in the audience. But now let's jump right away into the actual topic of today. And here it's first of all my pleasure to briefly introduce the two speakers that we have, which is Michael Bahr from Siemens and Xueli An from Huawei. So they are here in their capacity as chairs and vice chair of the Working Group 1 in 5G-ACIA. The Working Group 1 is focusing on use cases and requirements, so they're the right experts for this topic today. And Michael Bahr is a senior key expert, research scientist at Siemens Corporate Technology in Munich in Germany. He's working on the area of wireless networks and currently, of course, very much focusing on 5G. And he's also the rapporteur of 3GPP SA1 work items for communication for automation in vertical domains. So SA1 is the working group in 3GPP, in case you're not aware of that, who is focusing on its general requirements on the 5G system and use cases, of course, and things like this. And he's driving the corresponding activities or some of them. And then we have Xueli An. So Xueli An is a principal researcher from Huawei Technologies. And within Huawei, she leads 5G and currently also already beyond 5G activities related to vertical industries, especially. And this includes actual research, but also then industry development activities. So therefore, 5G-ACIA service is a very important component of that. So thanks, Michael and Xueli, for taking your time today, for preparing the talk. And with that, I would hand over, first of all, to Michael to start with the actual presentation of today.
Thank you, Andreas. So a very warm welcome from our side to the audience and the participants of the STEP seminar on industrial use cases and requirements. And let's start with a brief overview of our work and what we are doing. Working Group 1 of 5G-ACIA is concerned with the use cases and requirements for 5G in the area of industrial automation and manufacturing. The use cases range from industrial automation use cases, which are well established in real life and that are looking at utilizing 5G, over what I would call in the slide the current use cases, which would be the next innovation step to current use cases by using 5G for new additional functionalities. This can be, for instance, due to the increased mobility through wireless 5G communication. And as future use cases, I would call in the slides new use cases based on ideas that develop from the opportunities of 5G and are rather new and unprecedented in this area. The use cases come with requirements, of course, to the communication network. And if you remember the early days of the 5G discussions, there were several key performance indicators that discussed the what. You remember low latency, below 10 milliseconds, high reliability with multiple nines, high throughput with gigabits per second, scalability of thousands of devices. Such KPIs are important requirements. They are still important requirements, but it's also important to look at functional requirements and network operation, the how, in order to make the 5G networks usable for industrial automation and manufacturing. For both use cases and related requirements, it is important to translate from the real world and the application to the 5G network. The real-life applications have certain requirements on the industrial communication. They are already well established in working ecosystems in industrial communication. A translation between the concepts of industrial automation and 5G mobile communication is also necessary in order to foster common understanding between ICT and OT companies and to ensure the best possible applicability of 5G technology for connected industries, in particular the manufacturing and process industries, as it is written in the mission of 5G-ACIA. So let's jump to some selected use cases and requirements. And whoops, now you get the, and let's start with some general overview. So manufacturing is diverse and heterogeneous, and it's characterized by a large number of diverse automation use cases, which can be clustered into 5 application areas as shown on the slide. Factory automation, the automated control, monitoring and optimization of processes and workflows within a factory, especially including closed loop control application, robotics, motion control, and similar stuff. Process automation is the control of production processes and handling of substances, chemical industries, food, beverages, and this includes beer, which is very important if you live in Munich. Human-machine interfaces, that's self-explanatory. Things like panels and so on, logistics and warehousing, flow and storage, and making materials and goods available and moving them around in the factory, and monitoring and maintenance, especially condition monitoring and predictive maintenance with sensors, which are well-known examples. And we put these use cases from manufacturing on top of these application areas, and the use cases from manufacturing can be valid for a single application area or for 2 or even more application areas, as you can see on the slide. And this is one slide or one table or mapping from one of our white papers. So let's get to another live poll, since you practiced it already very well. Which is your favorite or most important application area? So one of the 5 we just mentioned within manufacturing. So let's see how low the latency in replies is, and if our fully automated manufacturing process for the poll results is favoring factory automation, which is also my favorite topic. It's of course the most demanding topic, as we will see very soon. And we are also very happy because our selected use cases are falling mostly into this domain. So from that point of view, it's a well fit between the interest of the audience and our presentation. So let's go on with the use cases. You see here the traditional automation pyramid that provides some structure for manufacturing and industrial automation from field level through all the different structures and organizational levels, through the control level, production cell, factory, up to the whole enterprise. And on the right-hand side, you see some sort of general rule, which is which is applicable in general, that the latency is more or less on the enterprise level and gets more demanding down to the field level, and similar to reliability. But however, the exception proves the rule, and you can find counterexamples on each level. And the slide, or the figure on the right-hand side, shows you the well-known 5G triangle of enhanced mobile broadband, massive machine type communication, and ultra-reliable low latency communication, URLLC. And our focus in 5G-ACIA currently, and also in this presentation, is on the use cases close to the right bottom corner of the triangle, the URLLC, although aspects of the other corners are, of course, also considered. Let's start with specific use cases now. The Industry 4.0 use case, flexible manufacturing with modular production systems and mobility, is actually a rather general use case. So static sequential production systems where everything is pre-planned will increasingly be replaced by novel modular production systems offering high production flexibility and versatility. This is one of the key characteristics in smart manufacturing or Industry 4.0. in the factories of the future. This includes a large numbers of increasingly mobile production assets for which powerful wireless communication and localization services are required. In the zones A, the blue ones, they are highly dynamic with respect to production processes and required communication resources. Dynamic configuration of communication services is needed, and there are areas included of flexible production and logistics, just with, or for instance, with AGVs and mobile robots. What is new, or which is the new demanding or challenging part, is that flexible production does not have any pre-planned production processes anymore. The production machinery is mobile, for instance, the mobile collaborative robots, and the production machinery and the associated communication will be configured for each production task dynamically by the production system, or even in a collaborative, self-organizing way by the mobile production machines and robots themselves as equal partners. And the production tasks are not known in advance, and the configuration for a production task does only happen when the production task is scheduled. Zones B have lower dynamics of production aids that are easy to plan. They might be static production cells with tools, machines, robots, video applications, and so on. And in order to handle the necessary dynamics and flexibility in the 5G network in a scalable way, the 5G networks need to support distributed mechanisms, such as a fully distributed configuration model for time-sensitive networking. On the next slide, you see sort of a little deep dive into this general use case. It's called flexible modular assembly area, but it's mainly about the communication of mobile assets, such as AGVs, mobile robots, etc. And of course, the modular assembly area is one of the major application areas of these mobile assets. The table on the left-hand side, you see some examples, or two examples of these AGVs and mobile robots. And the table, there you see some KPIs for the different kind of specific use cases or uses in this use case. The KPIs vary depending on the involved devices and processes. For instance, the transfer interval, the time between two subsequent messages in periodic communication. Some values need to, some values are depending on the actual use, and they are adapted with time, such as they also need adapted during the process of the development or further progress of these use cases, for instance, the message size. So you see here 256 bytes, which was the usual size 2 years ago, but now people think it's more than 512 bytes because the messages are getting more and more enriched with additional information due to the digitalization in manufacturing. Before we continue with the motion control cases, which will be presented by Xueli, I would like to point out the use case of the tool localization at the last row in the table, which also has positioning requirements on the 5G system.
Okay, thanks, Michael. So now I will continue with the motion control use case, which is considered one of the most challenging use cases for 5G. So in general, the motion control, it is a system that is responsible for controlling the movement of machines in a well-defined manner. So for example, you can think about the machine tools, packaging equipment, printing machines. On the left figure, it shows the typical industrial communication topology used in the current plant setup, which has 3 major domains: the public network domain, the enterprise domain, and the multiple OT production domains. As shown in the figure on the right side, so it is a closed loop control mechanism in which the motion controller periodically sends the target set points to the devices that take the actions. So here in the figure is an actuator that perform a certain action, like moving or rotating a specific component on the machine. At the same time, the sensors are used to determine the current value of the process. For example, what is the current position of the components? And then they set the actual values back to the motion controller in a deterministic manner. So during each communication cycle, the motion controller sends the update set points to all actuators, and the sensors send back their current values in order to complete the control loop. So in the current deployment in a factory, the motion control system typically uses the wired industrial Ethernet technologies, for example, Profinet and EtherCAT, which could support a really short cycle time, for example, in the order of a millisecond or even microsecond. So that's the reason, like we say, this is one of the most challenging use cases for 5G. In general, motion control has the highest requirement in terms of latency and communication service availability, as shown in this table. And the mean time between failure is normally around 10 years. So other than factory automation, closed loop control can also be used for the process automation. For example, in process automation, these components like the controller, actuator, and sensors, they are usually located in the environment which is much bigger size compared to the factory automation use cases. And then the next one is the control-to-control use case. So it refers to the communication in between the industrial controllers. For example, you can show on the left figure. So this kind of industrial controllers, which is also called PLC, which is short for the programmable logical controllers or motion controllers. There are two typical scenarios for the control-to-control use case. The first type of scenario is large-scale equipment. So basically, it means like you need to use several controllers to communicate with each other in order to perform a single big task. These control units typically need to be synchronized and exchange real-time data. And in general, this use case has a very high requirements in terms of latency and service availability. And the second type of use case is multiple individual machines that perform a shared task. So for example, you can imagine the machines on the assembly line. They need to communicate with each other to perform a certain task, like coordinate the handover of a component from one machine to the other, and so on. So in general, you can have like 5 to 10 machine modules on this kind of assembly line. And then the service area, the typical area is around like 100 meters by 30 meters and 10 meters. Then the protocol they use today for this kind of control-to-control is similar to the previous one, motion control. So they also use the industrial Ethernet protocols. And then we come to the left pole again. So this question is about the requirement. So which kind of requirement do you think is the most important one to enable industrial applications? Okay, now we can see the answers. So the first one, high availability and reliability. So it seems like more than half of the participants, they think this is the most important requirement. Okay, very interesting result. Then we can move to the next slide. This slide gives you an overview about all the requirements we are talking about. So in general, there are 3 dimensions of requirements: performance, functional, and operational requirements. So the majority participants, they choose the reliability and the availability, so that belong to the lower level, the key performance indicators. So these are the fundamental requirements in terms of quality of service that individual applications can expect it. Then other than the performance requirements, we also have a functional and operational aspect. So such requirements are very different compared to the previous generation mobile communication system. So this is because in current mobile communication system, if you can think about the 3G or 4G, the major business models is still based on selling the bits and bytes. So for which only this key performance indicator matters. However, this is not sufficient to support the vertical industry use cases. Then the example functional requirements, like how to utilize the non-public network, specific security demands, integration with the time-sensitive network, positioning capabilities, and so on. And then the third dimension is about the system operation and management. So example requirements could be how to provide guaranteed services and how to do 24/7 operations, how to provide the diagnostic capabilities, and so on. So in the later slides, we will touch a little bit some of the essential requirements which we have been working in 5G-ACIA. In order to guarantee safe and non-stop production processes and automation, a typical industry system should be operated constantly without any interruptions. This is the key to achieve a very high efficiency and the productivity. Any interruption of the communication system, even for a very short time, may lead to the application failure. So as a consequence, it can also cause increased administration overhead and extra cost to recover the production lines. Therefore, for use cases, we try to use performance attributes to describe the demands from the use case themselves. Some typical use cases are shown in the slides, like the end-to-end latency, transfer interval, survival time, communication service availability, and reliability. So all these parameters, they are together, they formulate the industrial expectations for the 5G system. However, this is not simply put a number after an attribute to say, for this use case, I need a 6.9 or 7.9 or 8.9. There are two major difficulties in order to understand these requirements. So the first question is, what are the relationships among each other? Do they have any dependency? The second question is, what are the OTs and ICTs understanding about these requirements? Are there any gaps or misalignment? So therefore, within 5G-ACIA, one of our major tasks is to try to provide and collect the relevant information from both the ICT and the OT partners. And we try to establish common understanding about these requirements. These are essential for 5G system design. So this figure gives you an example to build the links among the latency-related attributes. The overall picture contains the communication system in the middle and also the automation functions on the side. So for 5G system, the performance measurement begins from the communication service interface, so this CSIF within the communication device. Therefore, when we talk about the end-to-end latency, especially from the 5G system's perspective, it is defined as the time that if you want to transfer a piece of information from a source CSF to the destination CSF. So this is what we call the end-to-end latency. However, in order to understand if 5G system provides sufficient end-to-end latency requirement to run the industrial automation functions on top, this is not enough. We also need to know some further attributes like the transfer interval and also the survival time. So transfer interval is the time difference for the industrial applications to transfer two consecutive data from the industrial application via the communication service interface to the 5G system. And the survival time, this is also a very important concept. So basically, it defines or indicates the tolerance of the industrial applications against the unavailability of the communication service. Only by clarifying a big picture like this, we could understand how 5G systems play a role in terms of requirement satisfaction. So it is important to establish a link and common understandings among all these concepts. So we cannot say we already found all the answers to all these questions because we are constantly working on this topic within 5G-ACIA, even in nowadays. Then the next requirement is about the capability exposure interface. So as we introduced before, other than the performance requirement, there are also functional and operational requirements. And one of such requirements is the exposure of 5G capabilities via service interface. So this is quite a new requirement. Industrial applications like factory and process automation, as well as the production IT, they can utilize this kind of exposed capabilities from the 5G system, especially based on the non-public deployment. The important concept here is the exposure producer. if you see in the middle of the figure, which is a 5G function that implements the exposure services for the users of the 5G system. And on the other hand, the entities that use the exposed services, so for example, it could be the industrial IoT applications, are called as the exposure consumer. And the figure on the side also shows two types of reference point of a 5G exposed interface, ED and EN. So ED is the reference point at the device side. It is only accessible by local industrial IoT applications through a 5G modem. It is placed between the industrial IoT applications and the 5G system. And the EN reference point, they are exposed directly by the 5G core network. So by using such interfaces, ED and EN, it is possible to manage the user plane of a 5G system and enable use cases related to the device management. So for example, identity management, device provisioning and onboarding, and connectivity management, and so on. And another typical use case is network management related. Industrial applications can use such exposed interface to have access to, for example, quality of service monitoring of the communication service and perform management and operation related tasks. So the first phase result have been published in one of our white papers as well, which is released at the end of June this year, so it's quite new. And we are working towards the second version with further technical details and enhancement, which is in preparation. So if you are interested, you can find more details in the white paper. And the service level specification. So after discussing so many use cases and the requirements, what we want to emphasize here is that these are not only paperwork, which stays at a theoretical level. It is important to understand how to use them in real life. So for example, how to use them to design the 5G system, and later on, how to use them for purchasing, deploying, and operating 5G system for industrial scenarios. So service level specification, SLS, is one of the topics we are working in 5G-ACIA in order to reach this goal. SLS could be considered as the technical component of a service level agreement, SLA. I think this is a well-known term, which is a commitment between a service provider and a customer. It defines a particular aspect of the service that agreed between provider and customer. Industrial grade SLS and its corresponding management mechanisms are considered as one of the key factors for 5G system to support OT partners. Customer-facing SLS is essential for service provider and customer to establish common understanding between each other. Within the SLS, it could specify, for example, the service content, the capability, the performance, the response speed, and so on. Other than what could be delivered, it is also important for the OT customers to know what could be guaranteed and to which extent the promise could be guaranteed. So this is also essential for OT type of users. So SLS is more than definition of a set of parameters. It has a complete life cycle together with the 5G system. For example, the SLS could be tested before the deployment and constantly measured during the operational phase. And the OT customers can also evaluate the SLS based on the information provided by the 5G system. And all these components are essential to verify SLS as it is promised. So currently we have an active work item for this topic within 5G-ACIA, and hopefully we could report further results after the completion of this work item. Okay, then I will hand over to Michael.
You might have wondered why there are references to 3GPP documents in this presentation. And in this set of slides, I would like to explain how 5G-ACIA provides input to 3GPP and here especially to the 3GPP SA1 on use cases and requirements. So 5G-ACIA is a market representation partner of 3GPP, but not a so-called individual member of 3GPP. Direct contributions to 3GPP working groups by 5G-ACIA are therefore not possible. So individuals are here actually companies, organizations, or associations. However, several members of 5G-ACIA are also 3GPP members. And as you can see in the diagram, there are actually 3GPP members in all three categories of 5G-ACIA. The most, of course, in the ICT area. These 5G-ACIA members that are also 3GPP members can provide individual contributions to 3GPP. 5G-ACIA Working Group 1 discusses relevant topics of 3GPP SA1, and 3GPP1 SA1 collects use cases and normative requirements for the 5G network, so there's a very good match here. This provides a broader the discussion in 5G-ACIA provides a broader participation of the users of industrial 5G, especially the OT companies, since also the non-3GPP members of 5G-ACIA can contribute to the discussed 3GPP contributions, as well as the authors of these contributions get valuable feedback. And the discussions strive for pre-consensus between the 3GPP members within 5G-ACIA. This takes off some discussion load from the still always busy 3GPP meetings. Here you see our achievements within 3GPP SA1. The focus of the 5G-ACIA Working Group 1 is on the CAF topics, communication for automation in vertical domains and related topics. The figure illustrates the target documents of the contributions. The black 3GPP documents in the middle are the very CAF documents. Siemens is here the rapporteur of these documents. And the major document containing the normative requirements for 5G, for the 5G network and for the 5G-ACIA use cases is TS22104, service requirements for cyber physical control applications in vertical domains. Requirements with general applicability have been contributed to TS22261, the service requirements for the 5G system. However, you should note that requirements in 3GPP technical specifications only reflect what is considered achievable in the specific 5G release or what was achieved if the release is finished. In some cases, they do not come up to the actual requirements of the real use cases, but in most cases, it's quite a good match. And the development of 5G and making it suitable for industrial 5G is a continuous process over several 5G releases. Industrial 5G is nothing that is ready and completed within 18 months, the usual duration of a single 3GPP release. Industrial 5G will evolve over multiple 5G releases, and the pie charts at the bottom will give some rough guess on the covered industrial 5G functionality of a release, the green piece actually. And 5G started with release 15, mainly focusing on enhanced mobile broadband, but having also some improvements towards industrial 5G. And what I especially want to point out, the availability of local 5G spectrum for use with private 5G networks in several countries, for instance, in Germany in the 3.7 to 3.8 gigahertz band by Bundesnetzagentur. This sparked Barr's interest in experimenting with 5G release 15 already for industrial applications. Here you can see that release 16 will be the major, or will have the major block of functionality for industrial 5G, especially functionality for URLLCs for non-public networks, the initial functionality for the support of time-sensitive communication, quest monitor, and many others. Release 17 will have enhancements on the developments based on the developments of release 16, the enhancement to URLLC and non-public networks. There's further functionality specified for time-sensitive communication. There are also some enhancements to proximity services planned. And release 18 and plus is going for further and sort of finishing industrial 5G. There will be further, or there are necessary further enhancements to time-synchronized communication, for instance, the further improved time synchronization and fully distributed TSN configuration model. And there might be actually new industrial use cases which no one thought about for release 15. And with that, I would like to come up to our wrap-up, and I would ask Xueli for taking the first slide on
Yes,
the wrap up.
thanks.
I can move to it actually.
So if you followed our previous web seminar, our 5G-ACIA chairman gives a very good overview about what 5G is capable to do and why they are interesting for the industrial applications. So in this talk, we went a little bit deeper to understand the use case mechanisms and their associated requirements in detail. So I will not go to the details of this table. So it basically gives you an overview of what a 5G system could promise in order to meet industrial applications demand. So even though in this web seminar, we can only touch a subset of the use cases and the requirement, so it doesn't mean the others are less important. Then as a 5G-ACIA, we are constantly working on essential topics which could provide valuable insights that could even shape the future of 5G. And we share our understanding and conclusions via the format of white paper. So many contents of today's talk are from these 3 white papers, which are related to the use case and the requirement discussion. You could download them from 5G-ACIA website. And now Michael will conclude this talk. Yep, Michael, please.
Yeah, COVID-19 not only increased the number of web seminars, as you probably experienced by yourself, the number of web seminars globally presented and throughout the world, but also the number of things for takeaway, like in restaurants and so on. And here are our 5 takeaways from today's 5G-ACIA web seminar on industrial use cases and requirements. 5G-ACIA leads the discussions on industrial use cases and requirements for industrial 5G, both internally within 5G and also together with 3GPP and other organizations. 5G-ACIA works on common understanding and terminology of networking topics between ICT and OT. Several application areas in automation with many diverse use cases and requirements are looked at and investigated. Deterministic and highly reliable wireless communication will enable many industrial use cases and, as our poll showed, are very important. And 5G capability exposure and network management service monitoring are key for the operation of industrial 5G. And of course, we would like to encourage you to consider joining 5G-ACIA in order to progress how industrial 5G may support your manufacturing use cases. Thank you very much for your attention. And here again is the slide on further information about 5G-ACIA and our topics. And I now hand back to our moderator for some questions and answers.
Yeah, many thanks, Michael and Xueli, for this very nice overview of the topic use cases and requirements. Of course, you could only scratch the surface, so 1 hour certainly is not enough to really exhaustively cover all relevant aspects, but I think and I hope that everybody got at least a feeling of what is relevant here, what needs to be considered, and also what 5G-ACIA is doing. And of course, we have seen it's not just about defining a set of quality of service requirements or data rate and the latency and so on, but there are many more things that need to be considered, including this service level specification activity, for example, APIs, how to manage an integrated network, and so on. And these are all very important topics and also topics where we need this close collaboration between the ICT and OT side. And also I remember the very first discussions that we had, for example, on reliability requirements, when we were talking about packet error rates into order of 10 to the -9 and so on. So at that time, nobody in the OT world really knew what requirements we would have on 5G on a wireless system. But then, of course, over time, we had many discussions between OT industry and ICT industry, and then we came up with these concepts that have briefly been outlined with survival time, transfer interval, and so on. And these reflect maybe better what is really needed from the application perspective. So thanks for outlining this again. And we have now a couple of minutes left for some questions from the audience and answers, of course. So feel free to enter any further questions that you might have. I already picked some of them. And the first question I would like to bring up is basically a standard question that frequently comes up, which is the comparison against Wi-Fi 6. So Michael and Xueli, what would you see? What are the key characteristics that 5G really has compared to Wi-Fi 6, so that make 5G the only technology which we can realize a particular use case?
So both Wi-Fi 6 and 5G are very important mobile communication technologies, and both of them have their advantages and disadvantages. So from that point of view, of course, 5G-ACIA is concerned with making 5G suitable the best way for industrial use cases, but anyone who will use wireless communication for its use case will look at his use case, its requirements, and see which one of the technologies fits better to his needs, and then will deploy the things which fit into his factory. So there is no only 5G can do it. Both technologies are applicable to industrial use cases, and one has simply to decide based on the actual use case which one to use.
So, but would you see some use cases which Wi-Fi 6, for example, cannot realize, or in your view, that is it really possible to realize every use case with either technology? So I think this was the main purpose of that question.
There are some use cases where it might be, where the tendency goes towards 5G. There are some use cases where the tendency goes to Wi-Fi 6. And both technologies are evolving over the years, so it's hard to say that the use case can only be done by 5G. It really depends on the use case in the end, and you really have to do the analysis.
Okay, thanks a lot for that. And maybe then a second question, which is also always very relevant, is regarding the spectrum requirements. So could either Michael or Xueli, you briefly comment on what spectrum requirements industrial use cases have? So in which frequency band should we use 5G? Also, what are the bandwidth requirements? And then, how can spectrum regulators best enable 5G in the industry? And how do you see 5G in unlicensed spectrum, so 5G NRU as the keyword for industrial applications?
Yeah, I can try to answer this question. So in general, as a 5G-ACIA, we want to provide a general view on the problem. So if we see the spectrum, this is a highly regional dependent and also policy dependent. So therefore, in different regions, they may have a totally different regulations in terms of spectrum. So within 5G-ACIA, we have a dedicated working group working on this topic, and we try to collect the overview about the spectrum allocation and situation in a global scope. So I think we are working on some internal report. Maybe we will publish as a white paper. But if you're interested, please join us. And I think the discussions are very focusing on this topic. But of course, on the other side, we also have different work items, like we try to understand the traffic model in order to achieve or to get what is the required the bandwidth in order to run certain use cases. And this is the technical aspect we try to address from 5G-ACIA.
Maybe I can add a little bit here from the industrial point of view. So if you want to achieve high reliability in a wireless communication, you need to decrease your interference as much as possible. And this, of course, is best done if you have a licensed spectrum. And for just operating your factory, which is bound to a certain place in your country, it's not necessary to have a national license in order to achieve this. So the move of national regulators to provide local spectrum for use, for instance, in industries, is a very important decision and provided a big boost to thinking about industrial 5G in those countries. We can see that in Germany from all the activities on 5G campus networks, but this is really a key enabler to have some local licensed spectrum available for industrial 5G.
Okay, thanks, Michael and Xueli. So maybe we have time for one last question, which is about the development of the ecosystem of devices, of user equipment. So how would you see that? So when will there be UEs? When will there be chipsets and modules ready which support all these features that we need for the industrial domain, so be it Ethernet PDU sessions, TSN support, and so on. So what would be your expectation in this respect?
And I would say within 5G-ACIA, we have the right partners to work on the topic, because we have a quite complete partners from the ICT side, also the OT side. So this also included the chip vendors and also the device providers and so on. So the UE perspective, this is definitely also under the scope of the working group 1 in terms of use cases and requirement. The important thing is we need to clarify this, which kind of a specific requirement for developing the industrial UE. So I could foresee some new work item could be established, especially on this topic.
Yeah, but maybe to go a bit more in detail, so what would be your personal perspective? Of course, it's then very much about the chipset manufacturers, but I mean, many features are now part of Release 16, which just has been approved at the end of June. So when we expect to get corresponding chipsets and then also modules in the market, so that also the industrial automation companies can start offering corresponding products and devices? So how long does it typically take then from the availability of the standards to really the availability of devices?
This is not an easy question to answer. I would say this is really demand driven, because the standard ready is one thing, and if there is no demand after the standard is frozen, then still there is no motivations for the vendor to produce. But I'm very positive in terms of this aspect. So I can foresee the big interest from the OT side. Then this kind of interest will lead to the motivation for the vendors to develop new products.
No, of course, yeah, that's a very good point. So it's always this, depends on the demand, and somehow it's a chicken egg problem that we have, especially in the industrial domain. And we have to see how things further work out in the coming months and years. So looking at the time, I'm afraid we are already approaching the end of this web seminar, so time really flies. So I really would like to cordially thank Xueli and Michael again for taking your time today and for sharing some insights in the activities of 5G-ACIA on industrial use cases and requirements. Thank you very much again for that. So as announced at the beginning, the presentation slides and the recorded version of the web seminar will be made available afterwards. It might take a couple of days, so don't be impatient, but we are working on that. And also, there are more questions which we could not really address now during the event, but we will try to answer them afterwards offline and then get back to you with some replies to your questions. And I just would like to conclude now with a brief outlook again on the next web seminar, so which will take place on the 13th of August. We'll be focusing on non-public 5G networks for manufacturing, sometimes also called private 5G networks. We also have briefly heard about this today, so that's of course something new, so that did not really exist like this in the past. In the past, we primarily had these standard public networks, but now it's possible to set up non-public networks in a factory, for example. There are different ways to do that. This has been analyzed in detail in 5G-ACIA, and it's a pleasure to welcome next time Atelan Salmi from Nokia, who is the vice chair of our working group on architecture and technology, and who was also the rapporteur of the work item that was dealing with this topic so far. So certainly another very interesting and exciting topic. You can see from the time, I mentioned this also at the beginning, we try to make it fair for each region in the world a little bit. So next time it'll be late afternoon, Central European time. That means maybe a bit harder for Asia, sorry for that, but on the other hand, a bit more convenient for stakeholders in North America and South America. So we hope that, this is then equally fair to everyone. And of course, also the next web seminar will be made available online afterwards in case you cannot participate during the live session. So that would it be for today. Really thanks everyone for joining, for your interest in industrial 5G and 5G-ACIA. We hope that you enjoyed the web seminar today, and please feel free to get back to us at any point in time if you have any further questions. And of course, we hope to see you again next time, mid-August, or then during the next web seminar in September. Thanks a lot for joining. Thanks again, Xueli and Michael. Have a good day and talk to you again soon. Goodbye.
Thank you. Goodbye.
Thank you. Bye-bye.